अस्सलाम वालेकुम। DSP की एक नई वीडियो के साथ मैं हूं हम्माद अली। आज का जो हमारा टॉपिक ऑफ डिस्कशन है वो है डिस्क्रीट फोरियर ट्रांसफॉर्म DFT। फर्स्ट ऑफ ऑल वी नीड टू नो दैट फोरियर ट्रांसफॉर्म इज़ यूज्ड व्हेन we are dealing with non-periodic signals. On the other hand, Fourier series is used when we are dealing with periodic signals. If we want to convert a signal from time domain to the frequency domain, we use this formula, that is x of k is equal to summation n is equal to 0 to n minus 1 x of n exponent minus j 2 pi k n divided by capital N, where k is equal to 0 and it goes up to n minus 1. On the other hand, if we want to convert a signal from frequency domain back to the time domain, we use this formula, that is x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k exponent j 2 pi k n divided by capital N. Now let's look at an example in which we are given a signal x of n that is equal to 1, 3, 0 and 2. As you can see, n is equal to 4 and k goes from 0 up to n minus 1. Now we will obtain the values of x of 0, x of 1, x of 2 and x of 3 step by step just by putting in the values in the fundamental formula. For x of 0, we fix the value of k, that is 0, and change the values of n. First of all, we put n is equal to 0. Then for x of 1 we put n is equal to 1. For x of 2 we put n is equal to 2. And for x of 3 we put n is equal to 3. And as you can see, the value of k is fixed, that is 0. And by putting these values we obtain x of 0, that is 6. Now coming on to the next part, that is x of 1. We fix the value of k as 1 and change the value of n. First of all, n is equal to 0. Then for x of 1 n is equal to 1, x of 2 n is equal to 2, and x of 3 n is equal to 3. As you can see, the value of k is fixed. In these cases it is the value of k is 1, and by simplifying this we find the value of x of 1, that is 1 minus j. Now I will briefly describe the Nyquist theorem, which states that the sampling rate should be twice the highest frequency of that signal. As x of n is equal to 1, 3, 0 and 2, and x of k, which we have found previously, is 6, 1 minus j, minus 4 and 1 plus j. Now according to the Nyquist theorem, 4 is equal to 2 maximum frequency. 4 and 2 cancel with each other and becomes 2 is equal to f max. From the Nyquist theorem we obtained that maximum frequency is equal to x of 2 is equal to minus 4. So x of k is equal to 0, 1 minus j, minus 4 and 1 plus j. This is the base frequency. Whereas x of k is equal to 6, 1 minus j, 0 and 1 plus j. It is the higher frequency. Now let's consider another example in which we are going back to the time domain. Consider signal x of k is equal to 0, 1 minus j, minus 4 and 1 plus j. In this case n is equal to 4. First of all we will find x of 0, that is equal to 1 by 4. Summation k is equal to 0 to n minus 1 x of k e power j 2 pi k 0 by 4. Now in this case we will fix the value of n, that is 0, and change the value of k 1 by 1. First of all we have placed k is equal to 0, then k is equal to 1, k is equal to 2, and in the next part we have placed k is equal to 3. As you can see that the value of n is fixed, that is 0 for x of 0. By simplifying this equation we find x of 0 is equal to minus 1 by 2. Now for x of 1 we will follow the same procedure and fix the value of n is equal to 1 and change the value of k from 0 to 3. And by simplifying these equations, we find x of 1 is equal to 1.5. Now for x of 2, the procedure is same. You may have become familiar with this procedure and it may seem quite easy for you now. The procedure is same. You just have to fix the value of n is equal to 2 and change the value of k from 0, 1, 2 and 3, and you will obtain x of 2 is equal to minus 1.5. Similarly, for x of 3 we fix the value of n, that is 3, and change the value of k from 0 to 3. By simplifying these simple mathematical equations, we find x of 3 is equal to 1. In this way, you can go back to the time domain from the frequency domain. Hopefully you guys have understood the discrete Fourier transform and the process in which you can convert a signal from time domain to frequency domain, as well as from frequency domain to the time domain. That's all from today's lecture.